The topic of the video is the Bond's approximation in scattering theory of quantum mechanics. The scattering amplitude obtained by the Green's function method for asymptotic limit is given by f theta phi equal to minus mu by 2 pi h cut square into this integral, which is actually volume integral, and exponential minus ik dot r prime v r prime and then psi r prime d cube r prime, where r prime is actually the location in space where we have got the interaction or the target located, and then this psi of r prime is actually kind of the scattered wave function. The Bond's approximation is actually taking the scattered wave function as a plane wave with just in the same direction of propagation as the initial flux, which is k naught. So if you take it this way, then in the integral we can get this psi r prime replaced by this exponential ik dot r prime, and if you write both the exponentials which is here and here together, then we get exponential with k naught minus k into I dotted with r prime, and if you call this k naught minus k as another vector which is q, then we can get this kind of expression for scattering amplitude. And this can even be simplified if you take a special case which is called elastic scattering, in which the magnitudes of the scattered wave vector k and then the incident wave vector k naught will be equal. And if you assume the angle between these two vectors k naught and k has a delta, small delta, then we can actually kind of take a look at this figure where we have placed this k naught vector this way and then k vector this way. So our q vector, which is the difference of k naught and k, should be actually from up to downwards like this. And if we take a perpendicular onto this q vector, which makes angles delta by 2 here and delta by 2 here, then if you take sine delta by 2 either in this or in this triangle, then we will see ultimately that the length of this total q will be just twice I mean 2 times k into sine delta by 2. And if you assume the interaction potential is just dependent upon r prime coordinate but not on theta prime or phi prime, and if you also assume that this vector q, which is this one, is along z direction, I mean z axis, then we can see that the dot product of q dot r prime, I mean q and r prime, will be just q r prime into cosine of theta prime. Then the scattered scattering amplitude f can be again looked as minus mu by 2 pi into h cut square, and then the integral can be written as the volume integral for r prime, theta prime and phi prime, and as exponential iq dot r prime can be expressed as iq r prime into cosine theta prime, and then the potential is just v of r prime now, and then d cube r prime is actually expanded as r prime squared sin theta prime dr prime d theta prime d phi prime. And if you do the integral for phi prime, which is just 2 pi, then that 2 pi can get cancelled with this 2 pi which is in the denominator, so we can have the integrals for theta prime and then r prime. And to do the integration for r theta prime, we can actually call cos theta prime as x, so that we can actually see sin theta prime into d theta prime can be written as minus dx, and the limits when theta prime was 0 x will be 1, and when theta prime is phi x will be minus 1. So if you do the integration of exponential I q r prime x, then it should be exponential divided by I q r prime with the appropriate limits, minus 1 to 1, because when we want to remove this minus dx here, we can flip the limits here. So minus 1 to 1, and if you substitute the limits, it will become exponential I q r prime minus exponential minus I q r prime divided by I. But if you use the fact that exponential I theta is cos theta plus I sin theta, and exponential minus I theta will be cos theta minus I sin theta, so we'll be seeing that cos terms get cancelled, so we'll get 2I sin q r prime, and I also will get cancelled, and then one of the r primes here will cancel the r square d, I mean r prime square, one of those r prime squared, so we'll have r prime here and vr prime and dr prime. So finally what we get for the scattering amplitude is minus 2 mu by h cut square q into integration of r prime from 0 to infinity, and r prime vr prime sin qr prime dr prime. This is the expression for scattering amplitude in Bond's approximation, and this is actually for the elastic scattering. That's it in this video, and thanks for watching.